Today on NerdOut, Leios. Welcome back to NerdOut, the show where we break it down but don't dumb it down. Today we're talking about Leios, and for this talk, I have a very special guest, multiple times on the show. Welcome back to the program, Pi Lanningham.
Thanks for having me on.
Yeah, no problem. So today we're talking about Leios, and you're in kind of a very special position with Leios. You've been working with the team, doing a lot of the prototyping. Tell us a little bit about that, how Sunday Labs is involved, and kind of what's going on.
Sure. So around like April of last year, somebody that was working on the Leios team at the time reached out and said that they wanted to start getting members of the Cardano community more involved. They were kind of just finishing up some of the the Paris research work. And I said, that sounds awesome. And several months later, we got through procurement, and Sunday Labs started contributing to the Leios research project. And this can be a little bit confusing for people because there's already a paper about Leios published. So like, what more research is there to do?
What do you have to do? Why are you doing any work when the paper's already done? The work's done, right?
Yeah. And that paper really kind of makes a very strong argument about like the security and soundness of Leios as a consensus protocol. It kind of makes strong arguments about like the bounds on bandwidth usage and a node's ability to keep up with the volume of traffic and things like that. But it says very little about how to actually do it, right? Like what is the specific contents of an input block when you lay them out? How do you there's kind of like a one sentence, and then the ledger will resolve all conflicts. And like, okay, but what does that actually mean to the node and to the end user and things like that? A research paper is all well and good, but like, can we justify this finding, not just from a mathematical proof standpoint, but now from a real world standpoint? Because there's sometimes you come across like a mathematical proof that yes, this is totally sound, and then you deploy it in action, and like the kind of constant multiples add up, and you get, okay, well, we can only do like 1 TPS with this because in principle it lets you use all your bandwidth, but most of that is wasted or whatever.
And we've seen other places where this has occurred with Cardano, where it's like, okay, the research paper is good, but once they started implementing it, it's like, oh, well, no, we need to tweak this a little bit. And so they'll go back to the cryptography team and say, is this still secure? Can we change this window size or,
Yeah.
And so it is a little bit of back and forth. Once you get to the engineering section, you've got to go back and forth with the researchers and the engineers. And so give us a little bit of, if somebody doesn't know anything about Leios, I know we've been in the weeds talking about it. What exactly is Leios? Like?
Sure. So at a high level, Leios is an upgrade, a potential upgrade, because it still needs to be voted on by DREPs when we get there. But it's a potential upgrade to the consensus protocol, which is essentially the checklist of rules that every Cardano node runs in order to reach agreement on what the Cardano blockchain is. And this particular upgrade is focused on smoothing out resource usage so that we can scale up transaction throughput dramatically. And so, there's this fundamental question right now. And by the way, I wrote a very, very extensive blog post about this. You could probably find it in the description of this video.
Yes.
Like and subscribe, below. Blah, blah, blah. So, we probably won't go into quite as much detail here because we got limited time, but go read that if you're interested. But I lay out the fact that today, Stakepool operators are rewarded for operating the network. And the vast, vast, vast majority of that of that reward comes from emissions from a big pot of money that kind of was set aside when the network is initialized, the reserves.
Right.
And that dwindles slowly over time, meaning the rewards are dwindling over time. And right now, that's fine.
Like curve that's going down, whereas on Bitcoin, it's kind of, they do the halvenings where it's like stair steps going down.
Yeah.
So, kind of a nice curve.
But same idea. And today that's fine because it's still fairly profitable to run a Stakepool node, right? But as that dwindles, we need to figure out how is the network going to continue to pay for its own operation, right? If we were breaking in the fees at our current throughput, if like we were hitting 80% of the kind of utilization of the network, and that was enough to kind of fairly pay the SPOs, then it would be totally legitimate to say the layer one can stay very simple, and we can move a lot of if we want to be the global operating system, financial operating system of the world, maybe a lot of that traffic happens on L2s, and that's totally fine.
Mm-hmm.
But unfortunately, if you take away all the reserves and you just look at what we're generating at fees, even at kind of our maximum throughput, it doesn't come anywhere close to paying for, the infrastructure it takes to run it. So we've got to solve that somehow.
Yeah, and one way is to increase the amount of transactions. Another way would be to dramatically increase the transaction cost, but all of those things have trade-offs. Of course, if you jack up the transaction cost, then nobody wants to use it.
Yeah, absolutely, and that can create like a vicious cycle where you raise the transaction fees to bring in more revenue, and so people use the chain less, and so then you need to raise the fees again. And what we want to create is a virtuous cycle, right? That feeds on itself and says, okay, fees are low, so more people use the chain, so we can lower fees further, so more people use the chain. So that's kind of where we're at. There's also a couple other ways that we can kind of solve this problem as well. And, it's an important enough problem that we, I think everybody intends to attack the problem in depth. But Leios is kind of one of those dimensions. And the headline, is that in our simulation, there is no reason Leios cannot be pushed to 1,000, 3,000 TPS. And that's, I'm not playing any games there with, the size or complexity of transactions. That's looking at the average size and execution units of transactions over the last 2 years. If we take that as a baseline, 1 to 2,000 TPS is like very, very achievable with Leios. And, if you're willing to start making more and more trade-offs, you can push it even higher, right? We've done simulations pushing it up to 10,000 TPS.
Right. Yeah, because on Cardano today, most of the time of the network is sitting, doing nothing, just waiting. Average blocks are once every 20 seconds. Sometimes the network sits there for 4 or 5 minutes without a new block, and Leios kind of fills in those gaps with parallelism and endorsed blocks, I guess. So give us a little bit about what are the major changes, because it's kind of an overhaul of everything. Like, it's basically a new blockchain when you go to Leios, right, compared to what we've got
in
now.
some sense. And there's a lot of decisions ahead of us, and when I say us, I mean the Cardano community, about exactly how we get there and exactly how we roll it out. And some of those decisions can lead to less disruptive changes if that's what we prioritize. And some of them can be, we can say, well, if we're going to rip the Band-Aid off, maybe we do it now, and we just make the disruptive changes and deal with the side effects now when our market cap is only whatever it is today, 24 billion, and not, a trillion market cap. So I'm not here to kind of give answers to those, but maybe let me pull up my screen and I'll just use this as a visual aid for, so this is the blog post that I mentioned that I wrote, and you can see it ends up being quite long. Actually, I'll kind of make a quick aside here. That sustainability problem that I was talking about it seems to be if we can hit 50 TPS, then we've replaced the current reserves profitability. So, we are just as profitable.
Fee rates, correct?
Yeah, at current fee rates, right? And so then anything above that starts to become surplus for us to say, oh yeah, maybe we can reduce the transaction fees for users while still, resulting in higher revenue for the stake pool operators and the delegators. And so there's like lots of really interesting decisions in this space, and there's lots of really painful decisions in this space. And this red bar here is the kind of right now our maximum Preos throughput, somewhere in that range. So you can see like Leios, it really helps us get to this this break even point.
Right.
But if I jump down, where this diagram, and in this blog post, I kind of build up step by step to this diagram. So if you want to see how we get here, like why we arrive at this design, that's, go read this post. But at a high level, what we do is we run the existing Preos blockchain. And so each of these red blocks here at the top are just the normal Preos blocks that you have come to know and love. They're generated by Stakepool operators on a VRF schedule roughly every 20 seconds. Because we're doing less, there's also an option that we can change the timing on that. So maybe it becomes every 15 seconds or every 10 seconds because they're doing less work. But they use the existing Preos protocol, which gives us very strong guarantees about like the ordering and honesty of those blocks. In parallel, every stake pool operator is running, just as an example, 4 copies of the Leios protocol. So it's pipelined, and if you're not familiar with like CPU architecture or this concept of pipelining, a non-technical way to understand this is like when you sing "Row, row, row your boat" in rounds, where for these 5 seconds, some subset of the network is running one kind of stage of the protocol, and a different subset of the network is running a different stage of the protocol. And by overlapping them, that's what lets you, like you said, fill in those gaps. And so each of these Preos blocks that we publish is the end result of, basically a minute worth of work to produce that block. So that does mean that, one of the trade-offs that Leios imposes is a longer, just purely speaking, time to block. So from the time that you build and submit the transaction to the time it gets included in a Preos block, in Preos, it would have just been like, somewhere between 1 and 20 seconds on average, right? Sometimes a bit longer if there's gaps between blocks, but in expectation. And now there's no chance of that happening. Like it enforces a minimum delay on how quickly the transaction could get included in a block.
Right. So for an individual user, they might see actually a longer period of time, but the overall network will have a lot more throughput. Is that accurate?
Yeah, and even right. So like that sounds bad, but and we can dive into this deeper later. But there are other protocol upgrades that if we kind of pair these together with Paras, which is the fast finality protocol, then the perception or the lived experience of the end user is no different. Because today it's like, an average of 20 seconds to get into a block, and then several minutes where you wait for more blocks for confirmation. But if you have Paras, where each block is now like has very fast finality, okay, well now it's 2 minutes to make it into a block, and then it's basically instant, right? And so you end up waiting the same amount of time either way. So that's like a really nice property of how these two protocols interact.
Okay.
So what are each of these kind of pipelines doing? So in the first phase, right, which may last like 5 or 6 seconds, and we break that up into potentially many small subseconds. So like you can picture maybe 5 input blocks being generated per second across the network is kind of maybe a realistic number to expect. And so, in this 5-second period, that's like 25 input blocks, each of which might be 350 kilobytes. right? Which is already like 4 times as big as the current Preos blocks.
Right.
So like already you can see immediately where the additional throughput comes in, right?
Mhm.
Is allowing us to do those big and highly frequent blocks. And, you know, the blog post goes into why you can't just do that on Preos. And the whole design of Leios is about how you do that and then kind of settle on a final set of blocks kind of cogently.
Mhm.
But in this second period, we like kind of give time for those input blocks to propagate across the network.
Mhm.
And then we say, okay, everybody's probably seen the same set of input blocks. So let's have somebody propose a collection of those input blocks that we want to finalize.
Mhm.
And this is, you know, they're basically endorsing, you know, they say, oh, these 20 input blocks that I saw, this is what I think should be finalized on chain. And they kind of build that block and they propagate it out to all their peers, just like a normal block, but it's not
Mhm.
final. And then in this next period of time, all of the other stake pools are kind of downloading that endorsement block. They're saying, okay, you know, do I agree that this would be a good next step for the chain? Do
Mhm.
I have all the transactions downloaded? Do they look valid to me when I run validation against them? You know, things like that. And if so, they cast a vote, and that vote is weighted based on their stake. And so the idea here is once you've reached 70 or 80% of the online stake in terms of endorsing a block, you
Mhm.
have very high security guarantees that like that block is valid and that you're very likely um, to settle on that set of transactions.
Right.
And so we use kind of a technique borrowed from Mithril. The exact cryptographic primitive, you know, might be slightly different, but like you can picture it in the same way to say, okay, let's compress all of those votes down into a certificate. And
Mhm.
now I include that certificate in the Preos block that I produce. And I'm saying, okay, here is proof that 80% of the network voted on this set of blocks.
Right.
And what this does, the really subtle thing here is the reason we have to keep blocks small and keep relatively long quiet periods in between blocks is because um, the time, like there's nothing enforcing a minimum time between these blocks.
Mhm.
It could be based on the VRF lottery that a block is produced in the very next slot.
Right.
And in order for that block producer to know like what transactions it can include in the block, it has to have downloaded the previous block and finished validating it. So we
Mhm.
have that very tight 1 second time window where everything that you could possibly do in a block has to fit in, you know, that's downloading it and validating it has to fit within that 1 second window.
Right.
But with Leos, the only thing that you have to do to validate this block is you have to download like the block, which is now much smaller because it's, you know, and when we talk about these certificates, they're like 3 kilobytes, not 80 kilobytes.
Mhm.
So you just have to download and validate that certificate. You don't have to run any Plutus transactions because the certificate tells you that, okay, at least with 80% probability or 80% of the stake weight, this is going to be a valid block.
Mhm.
And if it comes up that the next slot is my turn to produce a block, well, I know that like I don't have to have finished reproducing the ledger state from this block. I can just go ahead and produce the next block, which references another endorsement block.
Mhm.
And so that allows me to, you know, we get a lot more breathing room in Preos,
Mhm.
meaning that like even if we're dealing with spikes of high throughput traffic, we know that like okay, in expectation over the long run, these are going to even out, and I'll be able to catch back up. And that's the big worry is that like if you allow too much throughput, well, your nodes are going to get into this state where they can never catch up, and so they stop producing blocks. And we see that sometimes with other blockchains of like
Yeah.
the network gets flooded, and so they have to restart the network and kind of discard a bunch of messages.
Right. So yeah, let's move on to another section. But in a
Sure.
nutshell, the main blocks are now just pointing to all these endorsed blocks. They don't actually
Mhm.
have the transactions in them anymore. They're very
Yeah.
small. They're easy to produce, easy to validate. The work is all getting kind of front loaded by these other three phases.
Yeah.
Okay. Yeah. So where does it go from here? Are there any maybe trade-offs to doing things this way versus the way it currently works?
Yeah, absolutely. And that's been the kind of primary objective of what we've been investigating. So for example, if I pull up GitHub input output Ouroboros Leios, this is the repository where we've been doing all this. So my computer is very slow for some reason, but so if you want to go and read through the code, it's all open source and all in the public. And Sunday Labs in particular has been building this SimRS folder, which is a Rust simulation of the Leios protocol. So we kind of emulate a bunch of nodes in memory and network links between them, and we track the bandwidth used by each link and all that. And we've been trying to uncover what these potential trade-offs are likely to be.
Mhm.
And you know, one of them, one of the main benefits, obviously, is throughput. And so this picture here shows you where Preos is. This like kind of blue green, sea green color is where we hit break even on costs. So as
Mhm.
long as we can hit this, we're good. And this color space is the set of um, transaction speeds that we think, again, average size transactions, not like
Right.
minimum sized, simple, wallet to wallet transfer transactions. This involves scripts and involves, heavy CPU stuff. We can very easily hit anywhere on this curve, depending on the trade-offs we're willing to take, which
Right.
makes it a very flexible protocol. The biggest trade-off, the biggest two trade-offs are going to be latency and cost. So
Mhm.
latency, there is this fixed added latency of like, depending on how we parameterize the protocol, about 30 to 60 seconds, where
Mhm.
from the time that you submit a transaction to the time that like you see it in a ranking block, um, is this fixed time delay. One surprising result out of our simulation directly is that this delay doesn't materially depend on the throughput you target. So
Hmm.
this is showing that like the curves are basically the same all the way up to 1,000 TPS.
That's awesome.
And so that's the a fixed time cost that if we decide to pay it, um, and especially if we can pair it with Paris, that makes this cliff a lot steeper now,
Mhm.
right? Then the end result is, you can see, we'll probably hit, if you imagine now Paris makes this curve a lot sharper, we would end up hitting the 90 to 100% confidence in the transaction at around the 40-second mark at the same
Mhm.
rate, or maybe a little bit longer if we use longer stage lengths. um, so I think that's a really kind of the main takeaway is, these two, we don't have to give up uh, a huge chunk of latency. Like the Visa network, they have like 24-hour settlement times, right?
Mhm.
So um, this makes us best in class from a performance standpoint without sacrificing decentralization in any meaningful way.
Right.
um, the downsides, the two big things that we're likely to kind of have a lot of debates about, is the cost. And the
Mhm.
cost comes from two things: the state growth, which is like the size on disk of all of these extra transactions, and that's not a property of Leios. That's just a property of higher throughput, right? If you have to store a lot of transactions, you have to store a lot of transactions, um, and that disk cost is expensive because you have to pay it forever, right? If you
Right.
produce a new block, it's not just a one-time cost. You have to pay for it until the Cardano blockchain, or until you stop running a Stakepool node, which for many Stakepool operators, they intend that to be forever.
Right.
And so, that being said, we're still kind of in the very small ballpark compared to some of the other, Ethereum is 1.3 terabytes. I think Solana is like up to half a petabyte, so like 500 terabytes of storage.
Yeah.
So, I think in the long run, this is a problem that we will have to solve with things like either compaction or, there's no
Sharding or
reason. Yeah, like
something like that, where some of the state is stored on different nodes. And
yeah, but like the key takeaway is that I think we have time to do that, right?
yeah,
The added burden isn't going to be so much that it prices SPOs out of running a stake pool.
yeah. So let's talk. I've got a question around that. So we're
Sure.
making a whole lot more blocks in general now.
Mhm.
We'll also have to take. I don't know if you covered this in your blog post or not. I don't think you did, but we're going to need to rethink the reward scheme most likely,
Mhm.
because there is some work that a stake pool operator should be rewarded for creating an endorsed block versus a final Proust block, and how and why, how will that change the financial model, and will it be
Yeah.
easier for very, very small pools or even individual stakers to make an endorsed block, or kind of how does that change the protocol?
Yeah. So the question or the answer is we don't know.
Okay.
In the sense that a lot of this is still in flux. We're still debating it internally and accepting feedback from the community. So one of the big objectives I had with writing this blog post is to instigate more people to email me, and I've gotten 2 wonderful, highly in-depth emails so far. So please keep them coming. Happy to respond. Happy to forward you and connect you with other people on the team who can answer your questions, etc. But in principle, the input blocks are produced a lot more frequently. If you're thinking like 5 a second, well, then
Mhm.
it's highly likely that we can reward that behavior. Not You're not going to make 500 ADA or 20 ADA per input block,
Right.
but the cliff between a stake pool that makes 0 and makes 1 block is pretty steep right now. And
It's
so
a very steep cliff. Yes.
this gives us an opportunity to smooth that out for people with lower stake. Um, the security team still needs to analyze that because, how does that play into the Sybil resistance? And maybe that's not as big of a risk because these are just like proposed input blocks, and they're not as security sensitive as the ranking blocks, and like so there's a whole kind of research line that still needs to happen.
Hmm.
There's also some really interesting um I want to emphasize what I'm about to say is not a decision that's been made or anything like that. And really, it's just my idea that I floated by the team.
Hmm.
They're still kind of digesting it, and it's a really recent development. But there's this idea where we're really still thinking deeply about this transaction conflict problem, which we
Hmm.
haven't talked about yet, but we'll talk about in a
Yeah,
second. But
we'll get to it.
there might be a design that the the incentives there's negative incentives for producing endorsement blocks
Mm.
where you pay to produce an endorser block and you're then compensated by all of the transaction fees that are collected there. And if you are like doing your due diligence to minimize conflicts, that's a net profit for you. But that might be a really interesting way for us to solve a particular remaining problem. So the point I'm making here, before we dive into what I meant by that, is the design space here is really huge and very, very sensitive to get right. So like, we're still looking at this heavily. We're still accepting input from people in the community and DReps. We're going to probably make a final recommendation just as the team that produces a final report.
Hmm.
But yeah, like this is an incredibly rich space to explore with some really interesting and exciting trade-offs for people.
Right. Yeah. So let's talk about some of those trade-offs. Let's get to transaction conflict. So right
Yeah.
now, we always say there are no failed transactions on Cardano. Like, you have to try really hard to make a failed transaction, and like have your collateral seized and all of that. Like, it's nearly impossible. There's maybe 4 or 5 on chain where somebody has intentionally had their collateral seized.
I think actually recently somebody created a bunch more, but yeah,
Okay.
it's all kind of like intentional testing
Right.
behavior. And so let me talk a little bit about that, right? So what that means is, this is useful in a context where we make the distinction between a rejected transaction and a failed transaction.
Okay.
Because this is a topic that needs a lot of nuance. A rejected transaction is one that, the script fails and you submit it to the node and the node says, hey, bud, that
Right.
we're not going to accept that. And it doesn't cause any undue burden on the network, right?
Right. Because
It's really
it
only the
never gets
node you submitted
published.
it to. Yeah.
Yeah.
Or maybe you submit a transaction and a bunch of Stakepool operators validated it to kind of include it in their mempool, including running scripts, actually, which is something that I didn't realize going into this, is like this whole phase 1, phase 2 distinction that we usually think of is actually kind of violated by the mempool, because every Stakepool is evaluating the transactions and the scripts anyway to include it in the mempool.
Right.
But it's at least bounded, right? In the sense that, okay, I'm going to include it in my mempool. And so for that particular space in a block, I can end up maybe validating one transaction for myself and then a different transaction when it gets produced. But it's still bounded. There's at most 2, right?
Right.
Not something somebody can create an infinite amount of work for the network.
Right.
And so the idea here is like, okay, if I submit a transaction that at the time I submitted is valid, but then maybe one of the inputs gets spent, or it gets unlucky and it expires before it gets included in a block. Well, at least it's cheap for us to reevaluate those conditions each time we see a block and decide, okay, is it, let's kick it out of the mempool really, and it, takes a couple of microseconds to make that evaluation because we don't have to run the scripts again.
Right.
And a lot of that behavior relies on the fact that in Preos, there is a single decision maker when it comes time to produce the block about what transactions get included in the block or not.
Right.
And that's the Stakepool operator who wins the VRF lottery. And occasionally that's not true. Occasionally there are height battles or slot battles where 2 parallel Stakepool nodes produce a block. But it's rare enough that like we kind of just brush that under the rug and we absorb that into the cost of running the protocol, right?
Yeah. Well, and it's it's
not
very
manipulatable by an attacker.
it'd be very, very rare, and like it wouldn't result in a failed transaction per se. It would just maybe be a lost transaction where if like your transaction wasn't a block, height battle, everybody had already removed your transaction from the mempool, height battle comes in, the new block doesn't have your transaction in it, and then your transaction is kind of poof out of existence.
Yeah, but like
it's possible.
The point I'm making,
very rare. Yeah.
Yeah, and the point I'm making is that 1, it's very rare, and 2, it's not manipulable by an attacker. They can't like expand how common it is. And so, if you took the hardline philosophy that every single bit of CPU work that the Stakepool operators do needs to be paid for, well, Preos doesn't pay for every bit of CPU work for exactly those cases, right? But because it's rare, we basically, it's like Walmart builds in some amount of loss, some amount of assumed shoplifting because they operate at such big scale and they're making such big profits that like the shrinkage isn't going to affect their bottom line.
Right.
And so we think of that wasted CPU effort kind of like shrinkage because it's a small enough percentage of what the network does that we can afford to just absorb it into the incentive model of the network.
Right.
And that's a really subtle point. So I'm like making sure to make that carefully. When we start to produce more transactions, there is a kind of, it seems like, and it's hard to state this like really precisely in a mathematical sense, but there seems like there is a tension between increasing throughput and making those serialized decisions at some level of throughput, which seems to be actually not much higher than what we're doing at Preos. You need to start making decisions optimistically in parallel, right? Some stake pool operator in Australia and some stake pool operator in New York need to make some decision to say, okay, this set of transactions is going to be included in a block, and we're going to kind of go forward optimistically in that sense, and then kind of just resolve any conflicts between those decisions later.
Right.
And once you start doing that, a lot of the assumptions that I outlined in kind of the setup to this problem start getting violated, and you start to like an attacker can create more and more of those conflicts, wasting more and more CPU, and it becomes either a denial of capacity, where okay, we have this super high throughput chain, but some troll thinks it's funny to occupy 90% of it, and it doesn't cost them anything. It costs them one transaction per block, which is like 0.2 ADA per block. And so they could just deny 90% of that 1,000 TPS. And, or even a denial of service where they're crowding out other legitimate traffic and not just kind of wasting that capacity, but actually damaging other people's ability to use the chain. And so as we push throughput up, we need to figure out, okay, how do we navigate that so that, one, it is expensive to execute those kinds of attacks, and two, the usual way to make it expensive is you make them pay for it. Unfortunately, that, just taken naively, that violates one of the big things we're proud of about Cardano, which is now, and I say naively because we do think we have some solutions to it, but just done naively, you get to the state on Ethereum or the state on Solana where you build a transaction, you sign it, nothing happens on chain. Like, you don't do the thing that you were trying to do, but you lose some of the funds in your wallet. And that's not great, right? And the kind of argument I make in this article is like, that feels like going up to like a Starbucks barista or tapping your credit card to buy a latte and them saying, sorry, the latte machine's being used, thank you for your money. And so we're exploring ways to deal with that, and there's a couple different ones. We could keep talking forever on this if you want, but the one that I'm a biggest fan of right now is this idea of collateralization, which says, what if we relax that condition slightly, where we say, okay, we no longer have perfectly deterministic fees, but instead of 2 outcomes, we have 3 outcomes. In one, you pay your normal transaction fees and your transaction makes it on chain.
Yes.
In another, you pay no fees and your transaction doesn't make it on chain. And in another, there's high contention, or you're trying to do something fishy, and so you pay an increased transaction fee, but your transaction does make it on chain. So you got to do the thing that you wanted to do, which is fundamentally different psychologically than the Ethereum or Solana world, where you pay for a service you didn't receive. Right? Now, there's some questions and some debate internally within the team on whether this is feasible, because by some analyses, which we're still debating, but by some analyses, some people are like, well, if you do this, does that collateralization factor have to be in the hundreds, right? Some people are making a very conservative argument to say, well, in reality, the extra fee case would have to be like 100 times the fee or 400 times the fee. I'm not yet convinced on that. I think that's like way too kind of conservative of an estimate for how easy it is to execute this attack. But if it was in the realm of like 20 times, then you go from like, and again, keep in mind, Leios is going to let us reduce the fees, but you go from like, 0.1 to, maybe 1 ADA or 2 ADA in the heightened fees, which, paying 10 cents versus $1, but you got your like important liquidation event on chain, or you protected yourself from liquidation, I think there's a lot of people that would take that trade-off.
Right. Yeah. Or especially, things that highly definitely need to get on chain, like Oracle services or things like that. They would always take that trade-off.
Yeah.
Yeah.
So
Oh, go ahead.
yeah, none of this is final. There's even another approach that we hadn't thought of when we wrote this blog that may be really interesting. I don't want to speak too much on it, but I was kind of alluding to it before, which is, if you think about it, the endorsement block here is in the best position to ensure that there are no conflicts, right? Because they happen roughly as frequently as the Preos blocks. And so they have a very similar property to being able to kind of avoid those conflicts. Not as well as the Preos blocks, but maybe it's good enough. And so if we have a scheme where, either the endorser block has a bond at risk and they're responsible for filtering out those conflicts, and there's some, doing that is tricky, because how do you let them filter out just one transaction out of a block of thousands of transactions that were in one of these input blocks? So there's a lot of subtlety in that. But if you make them responsible for that, and then you have a period where somebody can kind of slash their bond if it can be shown that they intentionally created conflicts, then maybe you can pull this problem back into the realm of no conflicts. Or maybe they pay to produce the endorser block, and then they get the fees from all of the non-conflicting transactions. So now it's not like a slash system, but they're just incentivized to create as few conflicts as possible.
Yeah, that makes sense. Yeah. Do you have any final thoughts on Leios, or what can the community or Stakepool community expect on this? I know we've been going for a little over 40 minutes now.
Yeah, I tend to talk a lot. I mean, the final thoughts is, please reach out to us. We've started to get some people, contacting us. And when I say reach out, like, tweeting at us is, delightful. We love to hear the feedback, but Twitter isn't necessarily the best avenue for having kind of deep, involved conversations. So, please show up to our monthly meetings. They're linked here in this blog post. Just email me directly and I'll get you involved in, kind of connected with the right people. If you want to kind of socialize this conversation in public, write something up, write your own blog post, and then post that on Twitter. That would be enormously helpful in kind of making sure that the conversation stays productive. And then the kind of what you should expect is, we hope to start being very concrete about prototyping this and sharing that with SPOs relatively soon. You can think sometime this year. We're trying to take a very aggressive timeline on Leios, because it's so critical to be able to attract new users of the chain, and to say, hey, as a business, we want you building on Cardano, and that you can, because there's all of this extra spare capacity that we can tap into.
Absolutely. Very cool. Well, again, thank you for coming on, explaining what's happening with Leios. It's always this, magic word that everybody sprinkles when somebody says Cardano can't scale, but Leios. So thank you for kind of opening the curtain on what Leios is, how it works, and
for sure. Thanks for hosting a show with such technical depth. It's really nice to be able to kind of go as deep as we did today.
Absolutely. So with that, nerd out.